All right, lesson 8.1 was all about triangles. So on pages 2 through 5 in your practice packet, we have a number of different triangle type problems that we're going to go through and answer. So starting with page number 2, the first question says, which set of side lengths could not be used to form a triangle? So because I'm trying to figure out which ones could not be a triangle, I'm going to take the first two angles and first two numbers, add and subtract, and figure out if that third number is in between. So 6 plus 2 is going to give me 8, and 6 minus 2 is going to give me 4. 7 is in between, so that one does work. 7 plus 5 is 22, and 15 minus 7 is going to give me 8. The third side is 8, so because it is that number right off the bat, right there, we don't have to go any further. That's the one that is not going to work here. I'm going to jump to number 3 just because of the spacing on here, and then we'll go down and do number 2, which shows the side lengths of the triangle below in order from the greatest to the least. So we're looking at sides versus angles. So I'm looking for my biggest angle, which is going to be right here, and that side is going to be AC. And following that, I'm going to go to 65, which will be the next biggest one. So that side is BC. And then finally 33, which goes across to AB. So I'm going to look down my list here. I have AC, BC, AB, and that's going to be letter choice B for number 3. Number 2, what is the missing angle in the missing angle measure in the triangle below? I'm going to go ahead and add 110 to 46. That gives me 156. And I'm going to subtract that away from 180. And that's going to leave me with 24 degrees then for our missing angle. In question number 4, which of the following shows the relationship among the side lengths of the triangle below? So it looks like we're going from least to greatest because it says this is less than this one. So we're going to take a look. So the least side is going to be across from the smallest angle, and that's going to be P. So right off the bat, it can cross off B and C. Looking at my two angles, the next smallest is going to be the 68, so that's going to be C. And that tells me then I'm at letter D then. For question number 5 on number 3, two sides of a triangle are 6 and 12. Which one could be the third side? So again, we're going to subtract. 12 minus 6 is 6, and add. 12 plus 6 is 18. So my sides need to be somewhere between 6 and 18. They are not allowed to be 6 and 18, so I cross those off. 5 is outside the range, so C at 10 inches is my answer here. I'm going to just do number 8 as well. That way we can just kind of move down the page. Mario's designing a logo. The logo is a triangle with a 100-degree and a 40-degree angle. What's the measure of the third? So I've used up 140 degrees. When I take that away from 180, I am left with 40 degrees. Our answer choice here is C. Which set of side lengths could form a triangle? So again, first two and then figure out if the third works. 4 plus 5 is 9, so I can tell that that's out right away. 8 plus 6 is 14, and 8 minus 6 is 2. 15 does not fit into that range, so that's out. For the next one, 12 plus 2 is 14, and 12 minus 2 is 10. 10 is a number here, so that's out, and I hope this last one works. 8 minus 5 is going to give us 3, and 5 plus 8 is going to give us 13. 12 is in between those, so that will work here. Question number 9, Brooke drew a triangle. One side is 6, another side is 11 centimeters. What could be the third? So we're going to do 6 plus 11, which gives us 17. We're going to do 11 minus 6, which gives us 5. 5 and 17 are arranged numbers. We're trying to figure out a number that's in between them. 3 is not in between, but 12 is. For question 7, which shows the relationship among the angle measures? So it looks like we're looking at angles as less than the other ones going up to the biggest. So we're going least to greatest here. So when I look at least, I also need the smallest side. So that's going to go to O first, which means I can cross off A and D. My next between 18 and 16 is going to go to X. So it looks like B is going to be my answer, and then side or angle V is going to be the largest because it's across from the biggest side. For question number 10, Elm Street, 3rd Street, and Maple Avenue intersect to form a triangle. What is the measure of the angle formed by 3rd and Maple? So we're looking for this one down here. So I'm going to do 121 plus 29, and that is going to give me 150 degrees. So if I take 180, take away that 150, I'm left with 30 degrees then for the missing angle. Again, I'm going to just jump to 12 because it's right next to us here. The traffic is assigned as an example of an equilateral triangle. An equilateral triangle has three equal angles. What is the measure? So we have 180 degrees in here. We're going to split it between 3. So each one in an equilateral triangle is equal to 60 degrees. Question 11, two angles are 25 and 50. The sides are 5, 9, and 11. Which statement is true? So if we know that two sides are 25 and 50, we can actually figure out the third side. So this gives us 75. If we take 180 minus 75, we're left with 105 degrees. So we know the sides are 5, 9, and 11. So 5, 9, and 11. We know that the smallest side will go with the smallest angle, will be across from it. The medium side will be across from the medium angle, and the biggest side will go with the biggest angle. So these are my sides, and these are my angles. So it says the 9 centimeter side is opposite the 25 degree angle. That's not correct because that's the smallest angle, but the medium side. The 5 centimeter side is opposite the 25 degree angle. That is correct because the 5 centimeters is the smallest and the 25 is the smallest angle. In part C, the 11 centimeter gets paired with the middle angle, which is why that's wrong. And in part D, it pairs the smallest side with the middle angle. So that's why that one is wrong. Number 13, again, we're checking lengths. 4 plus 5 is 9, and 5 minus 4 is 1. 6 actually is in between, and it says which could be used, so it looks like we've actually got this one already. Just looking at these other numbers, that's going to give me 4 when I subtract, which is why that one's out. If I add those, I'm going to get 21, which is why that one's out, and if I add those, I get 12, which is why that one also doesn't work. Page 5, this is your last page here. So we have question 14 at the top. Keith drew a triangle. One angle is 78, the other is 27. So what is the third? So we add up 78 plus 27, which gives us 105. So we take 180 in the triangle, subtract away the 105, and we're left with 75 degrees. For question 17, a triangle has an angle that measures 55 and an angle that measures 50. So 55 plus 50, we've used up 105. So if that takes away from 180, we're left with 75. So we have a 50 degree angle, we have a 55 degree angle, and a 75 degree angle. The length of the side opposite the 55 degree angle is 9 centimeters. So this is our middle angle, and it's also going to be our middle side. So what that means is that we need a length that is smaller than 9 to go with this one, and a length that's bigger than 9 to go with this one. So if I'm looking down my list, 6 is smaller, but 7 is not bigger. 7 is smaller, 10 is bigger, so we're going to have to talk about that. And then 10 is bigger, but 11 is also bigger. So we need to look here. Looking at these two choices, we can either say this is 3 and 12, or we could say this is 7 and 10. What we want to do is take a look at these angles. The angle difference here is not drastic. 5 degrees is a really, really teeny tiny difference. So we do not want to have a drastic difference in the length of our sides. So if I were judging based on this, having the 3 here would not be a good idea. We need a number that's fairly close to 9. So the 7 is going to be much more appropriate. Here, there isn't a totally huge difference there's a 20 degree difference, but once you are talking bigger numbers, that gets even smaller looking when you look at the sides. So that's why the 7 and the 10 is going to be the better option for things here. In number 15, an isosceles right triangle has a 90 degree angle and 2 equal acute angles. What is the measure of each of the acute angles? So since the angles are equal, we can take 180 and take away that 90 degree angle that's there. We're left with 90, and we can split it by the 2 angles that are remaining. Each of them are going to be 45 degrees. For 16, 2 side lengths of a triangle are 14 and 9. The third side is also a whole number. So the smallest possible length. So if I'm just going to be subtracting here, that's going to give me 5. So the smallest possible length would have to be larger than 5. So that would actually be 6. And that wraps it up then for your practice packet.